Hi everyone, welcome to Practical AI, Scaling Document Automation with DocCenter. My name is Ryan Goldberg, CS Innovation Lead at Appian, along with Jose Portillo. Our job at Appian is to ensure or really help customers adopt the latest and greatest AI features, making sure that you are building in the right and responsible way and evangelizing those best practices with AI. How many of you remember the first time interacting with an LLM? Perhaps you remember the first time asking an LLM to summarize, the first time putting XML tags in your prompt, the first time asking the LLM to output JSON. There's a lot of firsts to remember with large language models. What about the first time you uploaded a document and started asking questions about that document? It felt like magic. For years, we omitted document processing from our workflows because it was either too hard or traditional machine learning didn't deliver on that promise. But as soon as we introduced generative AI, or as soon as it came to the scene, we thought, well, this is pretty easy. I don't need a framework anymore. I could just prompt my way to a path forward. However, we know that there's a massive gap between a simple prompt that you can stand up in a couple minutes versus your production documents that you see in the real world. Now, what do those production documents actually look like, your documents? They are those 300-page contracts, those blurry scans of those documents that have bad handwriting. Maybe it's a document that was uploaded and it was rotated 90 degrees, so it's a little bit sideways. Your documents are those documents with key content buried on page 97 of a 300-page contract. And we really, really need to get that content on page 97 with a high degree of accuracy. Those are what real-world production documents look like. That's the reality. So we can't just write a simple, single prompt. It's not going to take us a couple minutes. We need the various tools in our AI toolkit and in DocCenter to think about how we can handle for each of these nuances, each of these sort of things that make DocCenter or that make extraction of documents a little bit trickier than just our happy path. We need to understand what tools we have at our disposal in DocCenter. So today, we'll be talking about a couple things: the strategy, build, the production conversations, and the reasoning. We'll hear about everything from selecting the right large language model, a fast model versus a thinking model, and what are the conversations that we need to have to test and actually move this to the next step to get this into production. Now, these aren't just theories. We've worked with a variety of customers, and these are battle-tested scenarios and battle-tested best practices that we want to share with you today. So here to talk about strategy is Jose.
Hi, good afternoon, everyone. So as Ryan has just mentioned, my name is Jose Portillo, and I'm also part of the innovation team. As Ryan has just said, we are going to start with the strategy, and you're going to see right now that your document automation process or your document automation journey starts long before you write your first prompt. This is the document automation workflow for a production in production, how it looks like. It has three different layers. There are classification, extraction, and reasoning. And now we are going to speak about all of them. The classification sets up the different categories or different document types that your process is going to intake. Then these documents are going to be sent or routed directly to their specific extraction models that will get the fields that are important for you or for your organization. And lastly, these fields are going to be validated so that they can be sent to your core business applications. And some examples could be performing some checks or comparing the different values. Once we understand this workflow, we can dive deeper into the intake architecture. At this point, and being a developer, the first question that we should ask ourselves is, how can I define a document category from the theoretical point of view? In this case, it's going to be the set of fields that you are going to extract afterwards in the extraction layer. We have, as you can see in the screen, one example in which we have one invoice and one PO. And as you know, there are some fields actually that can appear in these two kind of document types. What makes the difference here is that the set of fields that you need to take from each different document type is different from each other. This fact is what gives you the hint to, let's say, define a different document category. But, you know, guys, life is not that easy. The data in real world is messy, and we might even actually find these two invoice and PO documents in one single PDF. So what should we do in this case? Appian is aware of this use case, and actually there is a new feature called packet splitting, in which the document, this single document, can be ingested, and DocCenter automatically splits these two documents, the invoice and PO, and they are then automatically routed to the different extraction models. Once we know the solution that we want to implement, we need to think about how can I get high accuracy? How can I get these goals that I have set like requirements or at the requirement level? Well, in this case, both Appian product team and Appian CS innovation team suggest of refining your models with at least 25 verified samples. And why 25 or not 5 or 100? Well, in this case, in our experience, we have seen that 25 is the minimum number of samples or verified samples that actually can let you or can allow you to see the different format varieties that you might find in production. This is simple. Imagine that you are intaking an invoice or a model that is intaking invoices. You might have several vendors, which means several formats. So the more formats that you are aware of, the more formats that your model is refined with, you will get a higher accuracy afterwards in production. And then I'm super happy to share with you this complexity scorecard. In our experience, we have seen that these are the main factors that can impact the complexity of your process or of your project. So this is so simple. At some point, your tech lead, your project lead is going to ask you, that's great, you already know the solution, you are ready to start implementing, but how long or how many people do we need to put in this project? This is exactly what is answering, or thanks to this complexity scorecard, you can give your project lead a good estimate. You have on the left side the different factors, and then we classify them in low, medium, high, depending on your document features, document characteristics. Just to give you some examples, imagine that you have to process a form that is only 2 pages, it's always the same format, super clean PDF, and you only need to extract 4 fields. In this case, you've got your fields, you're going to say, yeah, this is going to be like low complexity, and I know that in 1 or 2 iterations of prompt tuning, I can get even above 95%. But then on the opposite side, imagine that you've got a huge, let's say, 60-page document, a scanned PDF, low resolution, you have to extract 20 fields. You know that it's going to take you way more time to reach this 90% accuracy, or 90+% accuracy. So the question now would be, what happens when you have some factors that are low, and then medium, and then high, so you have a mix of it? This scorecard, this complexity scorecard, can give you this example. And now Ryan is going to speak about how to actually build the solution. I'm going to give us some hints.
So let's talk a little bit about the actual kind of hands-on keyboard best practices that we wanted to share. So like with traditional software development, there's always trade-offs, right? Design trade-offs. So in our case, AI design is no different. These are the three biggest characteristics when it comes to thinking about trade-offs. If you do a design one way, how is it going to impact these three aspects? So let's think about if I were to write one big complex prompt versus a couple smaller prompts. We, as developers, need to know what that difference is going to be and how that impacts these three key factors. So for example, if I have one big prompt, is that going to use more or less AI actions than 2, 3, 4 smaller prompts? The tricky part is that there's not necessarily a one-size-fits-all solution. It's our job as developers to do a little testing, to do a little experimenting, so that we can go back to the business with some informed results and say, hey, tell me a little bit about your priorities. If we do design A, we'll have X percent accuracy. It'll take Y amount of seconds and consume Z amount of AI actions. However, here are some alternate paths we can take. It's our job to do these tests and to convey these trade-offs to the business. Now, what happens if I have my one big prompt versus 5 small prompts, and my 5 small prompts are in sequence? We know that it's probably going to take longer to execute those 5 small prompts in sequence. What happens if I change my design just a little bit and have those 5 small prompts run in parallel? How is that going to impact these 3 aspects so that I can find the right balance and sort of deliver the most value to the business? Again, it's our job to understand these nuances, to conduct these tests, and to make the right design decisions. What I find is that most customers will prioritize accuracy, right? The value that you get from having AI be at 98, 99% accuracy often outweighs some of the other drawbacks, like a little bit more AI action consumptions and maybe a little bit slower latency. Again, it really becomes this collaborative conversation. Now, let's talk a little bit about selecting your LLM. There's really 2 main categories: the fast LLM, which we'll put Haiku in that bucket, Claude's Haiku model, and there is the reasoning or thinking LLM, and we'll put Sonnet in that bucket as well. So the first decision, or one of the first decisions that we have to make, is based on our task and based on the document that we're extracting, which model should we select? So we'll typically recommend a fast model, such as Haiku, for those lower complexity documents, maybe a basic summarization, extracting a couple fields from a simple form. And we'll switch over to Sonnet, our reasoning or thinking model, for tasks that are a little bit more complex. Maybe if I was extracting from a 100-page doc, there's 50 fields that I need to extract, and each of those fields maybe isn't necessarily a key value pair extraction. There's a little bit of reasoning that I have to do. We'll use our reasoning model or thinking model, such as Sonnet, to complete that task. Again, understanding that Sonnet, our thinking models, might take a little bit longer to execute. We want to make an informed decision, again, on the trade-offs between accuracy and latency. Using Sonnet for something like a simple summarization is a little bit like using a cannon to swat a fly. You can do it. It will probably work, but it might not necessarily be the right tool for the job. Personally, I often challenge myself by trying to write my prompts first with Haiku. The reason being is if I iterate on the prompt, it essentially makes it so that I iterate. If I can get a prompt and get high accuracy with just Haiku, I know that my prompt is working pretty darn well. If I need, I'll bump it up to Sonnet for that extra kind of push to have that reasoning and extra intelligence from the LLM. You've probably heard the term prompt engineering. Hopefully you've heard the term context engineering as well. They're both very, very critical. Now, we have the concept of big chunks and small chunks. Again, do I want to have a big, complex task and maybe just one of them and have the AI do everything in one step? Or what is the right degree with which I can break down this task into smaller, more granular chunks? What is the right amount of content that I can give the AI such that it performs the task effectively, efficiently, and with a high degree of accuracy? Consider a DocCenter classification model that maybe has 30 or 40, 50 different categories that we need to determine. Option A is we can have one DocCenter classification model with all 50 categories. Option B is we might decide to have a two-step process where we have two classification models. An upstream high-level classification that says, is this a marketing doc, a legal doc, an engineering doc, and then route it to a more granular, more specific classification model. Now that I know this is a marketing doc, let's actually route this to my marketing-specific classification model. Again, like we talked about before, there's trade-offs to each of these approaches. If I take the big chunks approach and have one DocCenter classification model trying to do everything, it'll probably execute quicker, right? It's just one versus the two. It might use a little bit less tokens, and we have to do a little bit of experimenting, but it might not be as accurate, right? Doing this one classification model with 30, 40, 50 options might be a little bit of a complex task. So by breaking that down, in this example, into two classifications, our upstream high level and our downstream targeted classification, you can see how it starts to pull at the strings of this triangle, right? Our two-prompt approach will very, very likely get us higher accuracy, and how does that impact our other two characteristics? So the goal of context engineering is really to find the sweet spot. If you give the AI too much information, it might get confused, might take a little bit longer to execute. But if you give the AI too little information, it might not have all of the data or all of the sufficient context that it needs to complete the job with a high degree of accuracy. In the context of DocCenter, this might be adding a new paragraph in those high-level instructions to make sure that the AI is grounded in your task, in your process. It might be, on a per-field level, adding a new sentence that allows the AI to really understand what it means to extract this specific field. Generally speaking, adding these new sentences, kind of playing with the phrasing, isn't going to increase our AI action consumption too much, but will have significant impacts on our accuracy. So we really want to think about the right context. What is the right amount of information, or what information is the AI missing that it can then complete the task with a higher degree of accuracy? In DocCenter, we want to utilize test cases so we can mark specific documents as our test cases, so that as we make changes to these prompts, we can rerun those test cases and make sure that we didn't negatively impact our accuracy. And from there, we can continue to iterate such that we reach our place that we need to be, our confidence threshold, before we get to production. We also want to think about what it means to have a human in the loop, right? On one hand, there might be full automation, but depending on whether we take that big chunks or small chunks approach, what is that going to look like when we have a human review? If the AI gets it wrong, or even if the AI gets it right, think back to that classification example. If we do the two-step classification, where we have that higher level classification and then a more targeted classification, how is the human going to correct the AI? What is that workflow going to look like? So in addition to these three characteristics, we also want to consider just what that human-in-the-loop aspect looks like for us. Now, there's lots of little knobs that we can tweak in DocCenter to get our accuracy as high as possible. We've talked about model selection. We've talked about iterating on the prompt. There's even more that we don't have time to talk about today, such as advanced layout. But one of them that I really wanted to focus on is the idea of multimodal. This is our vision AI. Now, we're going to use vision AI, or we're going to check that checkbox to mark a field as a vision field for things like when we need to extract signatures, when we need to extract checkboxes, handwriting, anything that requires an understanding of the visual layout or the hierarchy of the document. My favorite example is a customer who came to us and they said, I have a document, and they were explaining that a red stamp on the document means one thing, and a blue stamp on the document means an entirely other thing. So as you can imagine, that is something that we could totally not handle without Vision LLM. When that checkbox is not checked, when we're not using a multimodal LLM, what's happening behind the scenes is essentially we're performing OCR, optical character recognition, and we get the wall of text on that document. Now, we need vision to get those checkboxes to understand the visual hierarchy, and when we're not using vision, it's simply just the text string from the document that gets passed to the LLM. A quick tip, we know a lot of customers have use cases where you're doing mobile uploads. So there's a feature in DocCenter that allows you to do auto rotation for those use cases where you upload a doc that is rotated 90 degrees. Especially if we're using Vision LLM, we want to check that box or check that feature to auto rotate the doc so that Vision LLM is actually looking at the characters in the correct orientation. But again, we always want to keep in mind those trade-offs. If I have some fields that are marked as vision and other fields that are marked as non-vision, how does that impact our trade-offs? Well, the reality is when I have some vision and some non, that's going to do 2 LLM calls. So it's probably going to increase our AI action usage. Might be a little bit slower, right, because I have 2 LLM calls. But again, that accuracy is going to bump up because I'm designing for high accuracy. I want to make sure that I'm using the right tool for the job. So I'll hand it over to Jose to talk a little bit about those production-ready conversations.
Thank you so much, Ryan. So we have already defined the strategy. Ryan has just given us some hints to build our classification and extraction model, and now it's time to hit production. When it comes to implementing automation, it shouldn't be required to just trust it blindly. Actually, at Appian CS innovation team, we prefer to talk about risk tolerance. So that this concept can help you to actually see when we should trust, or you should trust, AI outputs, or when you should put a human in the loop to review these outputs. So what you are seeing right now in the screen is the whole automation spectrum, where on one side we've got the full automation experience, or a straight-through process. That basically means that AI outputs are never reviewed by humans. On the other side, we've got the completely different opposite idea, that AI outputs are always reviewed by humans. But what happens when, by requirement, AI outputs should be sometimes reviewed by people, by humans? DocCenter can give you, or gives you, 2 different features that can help you to reach this point. First of all, through the sampling rate, you can, or DocCenter can give you randomly some documents, or can send some documents in a random way to the humans to be reviewed. And then on the other side, we've got the confidence thresholds. As you know, LLMs or AI systems can give you, or gives you, the confidence scores based on the information that they have extracted. Then this confidence score can be compared with the confidence threshold. And at the moment it is lower than that, it will be routed to be reviewed by a human. Having talked about this concept, I would love to dive deeper with it. First of all, confidence threshold is our way to quantify trust. So in this case, Appian CS Innovation Team recommends development teams to actually define this confidence threshold as a requirement at the beginning of the project, even before you start the development. Second is our confidence score goes from 0 to 100, and it is given at field level. What does it mean? That every single time your extraction model pulls out some information or some fields, every single field is going to give you a score, a confidence score. This confidence score will be compared against this confidence threshold that you have defined at the beginning of the project, and then you have set up during your model configuration. And in case any field confidence score is lower than this confidence threshold, it will be routed or sent directly to a human to be reviewed. Also, at Appian DocCenter, we've got what we call the Self-Audit feature. What does it mean? That you have an AI that reviews and flags any issue that might have happened during the extraction layer. So as you can see in the example, I hope that it can be seen correctly. On the right side, you have the document. You see one of the last lines. It says service tax, and actually it says $2. However, at the beginning, on the left side, it was subtracted $4. In this case, the AI review is telling us, hey, actually it was $2 instead of $4. So it is actually, again, flagging it even before a human reviews it. And now that we are talking about a human in the loop, I want to share with you that this interface is already part of the DocCenter solution. It is out of the box, so that you can increase the development, so the development time could be reduced. We understand that at some point, given some requirements, you might need to customize an interface, but having said this, from both product team and CS innovation team, we normally recommend, unless you have no other option, to make use of out of the box. And last but not least, this human in the loop, as we have mentioned, is actually to make some changes to reconcile the extracted information. And we understand that some of you come from highly regulated industries, such as pharma or financial services, and it's really important for you to understand or to record when a change is done. This is already automatically done through this out-of-the-box interface. Just in case a regulation organization comes to you and asks you who made the change, you have that information there in your system. So it not only tells you who, but also when and what was changed. So again, we have spoken about the extraction layer, the classification layer, and now Ryan is going to speak about the extraction one, or the reasoning one, sorry.
So with regards to reasoning, I want to introduce a new tool that our team has been working on. This is called the AI Rules Checker, and it's a new app that's available in the Appian app market. Now, similar to DocCenter, this allows us to write our rules in natural language. But unlike DocCenter, we aren't just extracting key value pairs to be populated on a form or to be sent to an external system. We've been talking to customers and really wanted an application that focuses on those back office checklists, those compliance validations, those long procedure documents that you have to work through to compare documents against each other, to compare documents against data, and really that checklist that you need to go through to make sure that everything looks good. So similar to DocCenter, we have different feature toggles that allow you to work through a variety of different implementations. The idea behind AI Rules Checker is that we can convert your procedure docs into a set of structured checks that need to be performed. And what we'll do is we'll pass the check definitions that you write either from your procedure docs or that you write in natural language. We'll define what constitutes this check passing. So you might say, pass if scenario A, scenario B, and scenario C, and fail this check if scenario X, Y, and Z. So the way that this will work is you'll pass in your documents, you'll pass in your data, and you'll pass in the checks that you need to perform along with those detailed check definitions. An AI Rules Checker will simply output the results. It's going to be a Boolean, true or false, pass or fail for each of those checks, and it's going to give you the thought process. It's going to have the metrics and accuracy tracking just like we have for DocCenter. There's different ways that you can use this tool. You can use it in embedded mode, which basically means that you can just use it as an engine inside your existing Appian application, or you can just use this as a standalone app. There's also different modes with which we can execute these rules. Single prompt mode is going to be good for our small documents where it's okay to do a full read. If we have smaller documents, let's say we have a couple 5-page documents, we can toggle that to single prompt mode. We'll do a full read and just execute the prompt. If we think back before about those trade-offs, in single prompt mode, we're going to do one call. It might use a little bit less AI actions, and we'll have to play around with accuracy. However, in agent mode, we're going to use this for a little bit more of our complex use cases. Think if we have a long procedure document which turns into 25 checks to perform. We have 5 different 100-page documents. We want to give the agent the autonomy to understand which documents it needs to look at, which ones it needs to do a full read of, which ones it needs to do a smart search or a semantic search to find different sections associated with those rules that need to be performed. So we're really excited to introduce this tool. Again, it's available in the Appian app market today. When it comes to agentic AI, up until this point, we've been thinking about DocCenter as a predefined workflow, right? You have your DocCenter, you call it as a sub-process, whether it be your DocCenter extraction model or your DocCenter classification model, and that is sort of a predetermined flow. But we know that agents use tools, and agents will use those tools autonomously. So let's consider what happens when we give an agent a tool of type DocCenter extraction or a tool of type DocCenter classification. Up until this point, our tools have been simple, records, data, expression rules, integrations. Let's break that pattern and actually give an agent access to these predefined, these pre-prompted DocCenter classification and extraction models, which we know already work with a high degree of accuracy. These tools effectively become knowledge for the agent. It's becoming a little bit more context aware, right? With the power of combining DocCenter, along with that React loop of an agent, it opens up a lot of doors for us. So just to summarize and to wrap up, we've talked about quite a few things today. We've talked about how to map the DNA, right? Understanding what makes a document complex. Is it going to be a 100-page document that makes it complex for you? Is it going to be 50 different checkboxes that makes your documents complex? Maybe it's those mobile uploads or poor quality scans or bad handwriting. Based on that complexity scorecard, we can start to have that initial conversation to understand the scope of what our DocCenter extractions and what our DocCenter classification models are and how they might be a little bit tricky for us. But more importantly, now we have the tools to actually identify how to handle those. Again, whether it be selecting the right LLM, whether it be using vision or multimodal in the right places, adding additional sentences, phrases, keywords, paragraphs even, in our DocCenter extraction model to make sure that we can continue to iterate, use test cases in DocCenter to bump it up over time. And we talked about trust but verify, right? What is the impact of AI getting it wrong? What is my risk appetite? If AI gets it wrong, is it a $5 million compliance fine? Or is it just a couple minutes that a human has to go in? These are the kind of the key factors that we want to think about when designing our DocCenter workflows and our DocCenter processes. So if you want to know more, we've got a couple sessions, one tomorrow and another one on Wednesday. Please feel free to attend. In addition to that, we've got some resources. We have Appian Academy, 2 courses that you'll see listed here. We have the new AI skill badge, which was mentioned this morning. Plenty and plenty of DocCenter documentation, which is constantly being updated with the latest and greatest best practices. And as always, feel free to log into the app and provide some feedback on the session. With that, I think we've got about 10 minutes left for any questions or comments. So we have a microphone. Feel free to raise your hand and we'll bring the mic to you and we can do some questions.
So you showed how you could take a simple engine like Haiku, do basic document classification, and then you showed how we can go to human in the loop on kind of the opposite side. Can we go from Haiku without going to human in the loop and call on something more capable of reasoning for outliers that aren't like 100% classified?
Yeah, that's a great question. So I want to share 2 techniques that I oftentimes recommend to customers with regards to classification, maybe 3. The first one is going to be examples. Examples are incredibly important to really make sure that our classification is highly accurate. What we want to do is anytime AI gets it wrong, we want to understand, well, did it get it wrong because it was kind of thinking about it the wrong way? Why did it get it wrong? 9 times, maybe 10 times out of 10, when I'm designing my classification models, in addition to the category or the answer that the AI gives, the classification, I will pretty much always recommend having the AI give an additional output for reasoning or thought process. That's going to make it so much easier to debug. If I have my reasoning or thought process field, if the AI misclassifies, all that you as the human or the developer or really any persona need to do is read that thought process. AI is going to say, I classified this as a quote because XYZ. If that's wrong, you simply take those lessons learned, feed that back into the prompt, and say, anytime you see XYZ, it's not actually a quote, consider it this other document type. So learning from the kind of lessons learned of previous misclassifications and that iterative kind of recursive loop is going to bump up accuracy. A couple other things to keep in mind. Oftentimes, I will have, if I'm doing a classification model, an option for other or unknown, right? I have my, let's say, 4 categories, marketing, finance, legal, and I'll always add one more output for unknown or unsure. That way we don't necessarily force the AI to make a decision. The last thing that I'll call out is with regards to confidence, there's a lot of ways with which we can engineer confidence from an LLM. I might decide an additional output. I have my answer, right, my category. I have my AI thought process. I might decide to add a third output called confidence, and I'll pass in a definition. Say, very confident means X, Y, Z. Somewhat confident might mean this other definition. And so I would oftentimes have those 3 outputs just for a classification model. The answer, the thought process, and have it give its own confidence. And the combination of all of those techniques most of the time will get you to that very, very high degree of accuracy with classifications. What other questions do we have? Over here.
You were talking about a process to identify when the AI is hallucinating. Trying to figure out when an AI is hallucinating is always kind of tricky. Can you walk through that process a little bit more?
Don't take that.
Can you repeat again the question? Sorry, couldn't hear you well.
The
Sure,
second
yeah.
LLM is a judge.
The second LLM is a judge?
Yeah, is that what you're asking? Like, so the question is how to basically handle for AI hallucination, what sort of tools we have at our disposal to kind of guard against that, right?
Exactly.
All right. You can actually, Ryan, to complement it. If I understood correctly, you mean At this point, when we've got the self-audit, we have the second LLM auditing what the extraction layer has already extracted, correct? So the idea here, and please Ryan, complement my answer. So the idea here is that the way the second LLM or the prompt behind the second LLM is completely different of what we've got for the first LLM. It's targeted mainly to get for specific fields, for the ones that you as a developer said, to check if the information has been extracted correctly or not. So the idea behind it is to actually enhance the user experience for the human to review it, so that it flags the fields or some discrepancies between what has been extracted at the beginning and then what this second LLM has set up. I'm not sure, Ryan.
Yeah, the other thing that I would add, which is really important, I'm glad you asked this question, is thinking through what business rules we can put on top of our extractions to give us a better sense that the AI was doing what we expected it to do. I'll give the example of extracting from a driver's license. If AI extracts an expiration date of 1872, we can say pretty confidently that AI probably did not get it wrong. But the interesting thing is checking that the date is 1872. That's kind of a separate step, right? AI is going to extract 1872. What are all of the business rules that we can put on top of the extractions? So after the extraction happens, we can say to ourselves, you know what? If we ever extract an expiration date from our driver's license that is before the certain date or after the certain date, route it to a human because something went wrong. So it's really, really important not only to think about the self-audit and the AI as a judge, but there is a world of business rules that we can put on top of this to give us a little bit more confidence that AI is doing the right thing. It might be in the form of a date. It might be in the form of a number, right? If I have a quote and AI extracts a value of -100, again, it's not necessarily, we don't need an AI to tell us that -100 seems a little fishy. I can put that in simple Appian expression rules in my post-processing after the AI extraction happens. Again, putting in all of these things that essentially edge cases or would route to a human. And so what we can do, if we have a robust rule set, 1 to 15 business rules, and they all pass, that gives us even more confidence that the AI probably extracted correctly. I think we've got time for maybe 1 or 2.
You answered one of my questions, the business rules. But to add on that, you mentioned business rules. Is self-audit just like predefined business rules?
So a little bit different. In DocCenter, basically what we can do is self-audit. I believe you can mark specific fields for the secondary review. And then you'll have business rules, which is a separate section of DocCenter. I think in DocCenter they're called post-processing rules. So you can do post-processing rules at a per field level, but then also at sort of the overall level. So if you need to compare extracted field 1 to extracted field 2, that is all facilitated in DocCenter. But those business rules are essentially expression rules that you define versus that self-audit or second LM as a judge is more so a feature that you just flip on per field.
Okay. Is there like a special place where you can see the predefined checks that the self-audit's doing?
Yeah, it'll be, if you want to hang on after, but it'll be in the DocCenter creation wizard.
Okay, gotcha. Just one other quick question. You mentioned about like color vision, like understanding like colors. Is that just the AI just defining, just the model just looking at the document? How do you activate that?
Yeah, so there's a field at a feature at the per field level in DocCenter. I believe the column is specifically called visual. You'll simply check a box, and what that'll do is route not necessarily to the OCR LLM, but it'll route to our vision LLM, our multimodal LLM. So whether it be looking for things like color, checkboxes, signatures, it will effectively.
Can sound be one?
I'm sorry?
Can sound be one?
I wish.
Okay.
Not yet. it'll effectively look at the document, right? It'll understand the visual hierarchy, and it will see things, not just the raw OCR of that document.
Thank you.
Okay, I think that takes us a little bit over to time. Looks like we have maybe one more urgent one. Go ahead.
Do you mind share your OCR LM model you are using? And if you use multiple model, do you see the difference between
Yeah, so
models?
right now, and when Appian AI was released, the underlying models were the AWS or Claude Anthropic family of models served through AWS Bedrock. If you'll talk to our product and engineering teams this week, one of the things that they're excited to talk a little bit more about is introducing new models outside of the Anthropic family. All right, thanks everyone.
Thank you so much.